It weighs less than 40 pounds, and in World War II, this machine helped power America's air defense. The engine displaces barely 5 cubic inches, and the whole thing fits inside a wooden carrying case about the size of a suitcase. On paper, the PE-214 looks like a toy, a 300-watt gasoline generator built by Jacobsen Manufacturing of Racine, Wisconsin, a company better known for making lawnmowers. But here's the thing about small generators in wartime. Nobody remembers them because they weren't supposed to be remembered. They were supposed to keep running in the background while the equipment they powered did something extraordinary. And in the case of World War II, that something was tracking enemy aircraft before they reached American soil. Portable power became the invisible backbone of America's air defense, the technology that enabled every other innovation the war produced. And the story behind it starts with a machine most people would walk right past. On the morning of December 7, 1941, 2 Army privates named Joseph Lockard and George Elliott were pulling the last minutes of a training shift at a radar station on Oahu's northern tip. The station was called Opana Point, and the equipment they operated was an SCR-270, one of the Army's first mobile long-range radar sets, developed at Fort Monmouth, New Jersey by Signal Corps engineers, and capable of spotting aircraft formations more than 100 miles out. At 7:02 that morning, the oscilloscope lit up with a return signal so large that Elliott thought the set had malfunctioned. It hadn't. What they were looking at was the incoming Japanese strike force, 132 miles away, closing fast. They called it in. The officer at Fort Shafter's Information Center, Lieutenant Kermit Tyler, told them not to worry about it. He assumed they'd picked up a flight of B-17 bombers expected from the mainland. 45 minutes later, the first bombs fell on Pearl Harbor. What's easy to miss in this story is everything that had to work before that blip appeared on the screen. The SCR-270 was a 4-vehicle system, and one of those vehicles, a dedicated K-31 truck, carried nothing but the generator. Not the 300-watt PE-214, but a 25-kilowatt PE-74 built by Westinghouse, an engine-driven unit that burned roughly 4 gallons of gasoline every hour. The radar that caught the Pearl Harbor attack needed almost 100 times more power than that little Jacobsen set could deliver. So the PE-214 didn't protect America's skies, at least not directly. The truth is more interesting than that. The American air defense system that took shape after Pearl Harbor wasn't just radar. It was a sprawling network of human observers and radio operators, telephone lines running into filter centers where volunteers, mostly women, plotted aircraft tracks on enormous table maps while officers directed interceptors overhead. By 1943, nearly 1 million civilians had volunteered for the Aircraft Warning Service, manning more than 14,000 observation posts around the clock from Canada to Key West. When a spotter saw or heard an airplane, they picked up a phone and called a flash report into the nearest filter center. But in remote coastal areas and on Pacific Islands where telephone lines didn't exist, those reports went out over radio. And every one of those field radios needed a power source. That's where generators like the PE-214 earned their place. The Signal Corps maintained a whole family of portable power units ranging from the tiny PE-77 at 250 watts, used to keep field radio transmitters alive at remote observation posts, all the way up to the 10-kilowatt PE-95 that powered mobile communications trucks. The PE-214 sat near the bottom of that range, purpose-built for field communications equipment. Small enough for 2 soldiers to carry, reliable enough to run for hours on a single tank of fuel. I think what makes this worth understanding is that none of it was glamorous. Nobody gave medals to the generator that kept a radio transmitter alive on some unnamed hilltop in the Aleutians. But without that steady 60-cycle hum in the background, the entire reporting chain, from the spotter's eyes to the fighter pilot's headset, went silent. If one company's story captures how portable power went from a curiosity to a strategic asset, it's Onan. David W. Onan started his business in Minneapolis in the early 1920s, building electrical tools, and a tabletop circular saw he marketed as the Safety saw. The generators came almost by accident. In 1927, he took a small Briggs & Stratton engine, coupled it to a converted electric motor, and built a 350-watt DC generating set he called the 10-light, because it could keep 10 light bulbs running for 12 hours on a single gallon of gasoline. The 10-light was designed for rural families living beyond the reach of city power, which in the late 1920s still meant most of the country. It sold well enough to shift the entire company's direction away from saws and toward generators. When the war started in Europe, Onan's first major military customer wasn't the United States, it was Britain. Starting in 1939, the British ordered hundreds of small AC generator sets to power military radio transmitters, and their field reports were favorable enough that the U.S. military took notice. By 1942, Onan had converted its entire production to military contracts, building dozens of models from 350 watts to 35,000 watts. According to company records, Onan produced more than half of all the portable electric plants used by Allied forces during the war. That's a staggering number for a company that had started out 15 years earlier with a converted motor and a Briggs & Stratton engine in a Minneapolis workshop. The technology that made air defense truly lethal came from an unlikely exchange. In September of 1940, while the Battle of Britain was still raging, a small British scientific delegation, the Tizard mission, crossed the Atlantic carrying what may have been the most valuable piece of military hardware ever transported in a suitcase, the cavity magnetron. This device could generate microwave energy about 100 times more powerful than anything American labs had produced, and its arrival led directly to the creation of the MIT Radiation Laboratory, where some of the war's most consequential radar systems were designed. The one that mattered most for air defense was the SCR-584, manufactured by General Electric. It was a compact, automatic tracking dish antenna radar that could lock onto an aircraft and feed continuous position data to an electronic fire control predictor. Specifically the M9 gun director, an analog computer that calculated firing solutions faster and more accurately than any human crew. Paired with the proximity fuse, a shell that detonated itself when it sensed it was close enough to a target, the SCR-584 and M9 together turned anti-aircraft gunnery from a probability exercise into something closer to precision. It was a triad: radar, computer, and fuse, and all three had to work together. The proof came during the summer and fall of 1944, when Germany launched V-1 flying bombs against London and later against the port of Antwerp, what the British called Operation Diver. In the Antwerp defense alone, batteries directed by SCR-584 sets destroyed roughly 90% of the incoming V-1s within about a month of deployment. Over 1,600 more were shot down in the defense of London. Every one of those radar sets ran on a generator. The same went for the M9 gun directors feeding targeting data to the guns and the communications equipment linking batteries to plotting rooms. None of it worked without an engine-driven generator running somewhere nearby, usually operated by a crew that never got mentioned in the after-action report. When the fighting stopped in 1945, the United States had an enormous surplus of military generators and an entire industry that had learned how to build them at scale. Onan pivoted almost overnight back to civilian production, supplying private label generators to retailers like Montgomery Ward and Fairbanks Morse before expanding into the RV and marine generator markets that would define the modern backup power industry. The company eventually became the core of Cummins' power generation division, which is part of why you'll still find the Onan name on generator housings in campgrounds and marinas across America today. Jacobsen, the company that built the PE-214, went back to making lawn mowers and turf equipment. If you've ever seen a commercial mower on a golf course with the Jacobsen name on it, that's the same Racine, Wisconsin operation that once stamped Signal Corps, U.S. Army onto 300-watt field generators. There's something worth sitting with in that transition. The war proved a simple idea that the civilian market would spend the next 80 years confirming, wherever the electrical grid can't reach, a compact gasoline generator becomes the most critical piece of equipment on site. That was true on a Pacific island in 1943, and it's true in a Florida neighborhood after a hurricane knocks out power for 2 weeks. The PE-214 never tracked an enemy aircraft. It never powered the radar that caught the Pearl Harbor attack or guided the guns that shot down V-1 flying bombs over Antwerp. But it belonged to the family of machines that made all of that possible, and the industry it helped create is still the reason millions of Americans can keep the lights on when everything else goes dark.